Assalamu alaikum. The next sampling distribution is T distribution. T distribution is actually the ratio of a standard normal distributed random variable along with the square root of independently chi-square random variable divided by its degrees of freedom. For this, it may be written in the form that Z has a standard normal distribution and U has a chi-square distribution with k degrees of freedom. Then we have this sort of ratio with us which follow the T distribution. By definition, student's T distribution is if any random variable following this particular equation, that is equation 31 of the book, then that is defined as the student's T distribution, or we may call it as the student's T distribution with k degrees of freedom. Now for its derivation, we have a theorem with us that if Z has a standard normal distribution and U has a chi-square distribution with k degrees of freedom, that this particular ratio will follow the standard student's T distribution. Now for derivation purpose, as we have given in the statement that Z is standardized distribution, so standardized normal distribution with the interval minus infinity to infinity and density over here, and U is following the chi-square distribution with k degrees of freedom, which is here. And since both are independently distributed, so it's easy for us to find its joint density by taking simply the product of the two. We have this sort of joint density with us. Now the purpose is to find the T, the distribution of this T, which is actually the ratio Z over square root U over K. For finding it, we will follow the transformation method, and by transformation method, as you know, that we will convert it into some other variable. So solving it for Z, we have this one, and let V is equals to U, we will get in the form of V is equals to U, Z will become this one, and then we need the Jacobian over here. By solving Jacobian by its formula, we will get the value as square root of V over K. Now putting all the results, all the transformation into the joint density, we have new joint density as GTV. We will convert our U into V while our Z into T. So we will get this form, and then simplifying it, we have a particular joint density of this one. Now the basic purpose is finding the density of T, not the joint density. So finding the density of T, what we will do, we will find over here the marginal density of this joint distribution. Marginal density may be found by taking the integral over the variable V and solving it. We have the gamma function, and then simplifying it, we have the final density that is given over here, the h of T with the interval minus infinity to infinity. As you have seen that this one is the same as given in our equation 31, which is over here, so we can say that T is following the T distribution. Next is the corollary, that if we are not taking the Z and U simply, but we are taking X bar, which is normally distributed, and then converting it into its standard normal variance, and U is since chi-square distributed, but the formula of chi-square variable is this one. Now here degrees of freedom is n minus 1. So then our T will become Z over square root of U over n minus 1. Now we have replaced K with n minus 1. Now simply solving this particular equation, putting the value of Z, putting the value of U, and then simplifying it, we get the result as this one. We have converted that summation xi minus x bar whole square over n minus 1 into s square, as we know. That is the formula of variance with its degrees of freedom n minus 1. and this is the particular value of t which is following the t distribution with n minus 1 degrees of freedom. Next is the mean and variance of t distribution. For finding mean and variance, we have the formula, we have the values. By definition, we will solve it. As we know that t is equals to z over square root of u over k, and for finding its mean, we need to take its expectation. By taking the expectation on the basis of independence, we may write these two as separately, that expected value of z into expected value of 1 over square root u over k. Now, as we know that z is standardized normal distributed, meaning having its mean as 0, so expected value of z will become 0, and on the basis of expected value of z will become 0, this whole term will be 0, showing that the mean of t is 0. Now for finding variance of t, we have the formula expected value of t square minus expected value of t whole square, as we have done earlier that expected value of t is 0, so we will left with only expected value of t square. Now solving it for variance of t, again we take its value, that is expected value of z square over u over k. On the basis of independence, we may write it separately. Then we know that then again on the basis of z is following the standardized normal variable with 0 mean and unit variance, and on this basis we have expected value of z square is equals to 1. Now for finding expected value of 1 over u, as we know that u is following the chi-square density, so we will use over here the chi-square density along with 1 over u. Solving it, we will get its value as this one. Now simplifying it, the finally expected value of 1 over u will become 1 over k minus 2. Now by putting it into expected value of t square, we have k into 1 over k minus 2. So the final answer of expected value of t square is k over k minus 2, which is the variance of t, with the condition that k should be greater than 0. Hence, mean of t is 0 and the variance of t is k over k minus 2 for k is greater than 2. That's the end. Thank you.